In this review video for the Unit 5B test, we're going to be looking at solving quadratic equations using the quadratic formula. We have two examples, one where we will get two solutions and one where we are two real solutions, and then one where it'll be two imaginary solutions. So let's take a look at this first one. This is number 20 from the review. Again, you can see the equation 3x squared minus 8x minus 8 equals 0. If it's not already set to 0 on the test, you'll want to set it equal to 0. You can always check to see if you can solve by factoring, but when you can't, we use the quadratic formula because we have an AX, we have an A, B, and a C. So we have to use a quadratic formula. In this example, you can see I just plugged everything in. And when I found the discriminant, I got 160. So we have 8 plus or minus the square root of 160 over 6. Okay, so 160 is going to have to be simplified. So I work that over here, 16 times 10, and of course 16 is a perfect square, 4 times 4. So that 4 comes out here. And then 2 times 5 is left, and that's 10, so we just leave 10 in the radical. And then all that's divided by 6. So now I just need to simplify 8 over 6 and 4 over 6. They all have a 2 in common. 8 divided by 2 is 4. 4 divided by 2 is 2, and 6 divided by 2 is 3. So this is our final answer. All right, now let's take a look at another example. Okay, so in this problem here, which this was not actually on the review, but I wanted you to see one like this because it's kind of like one on the test. So we have 0 equals negative 2x squared minus 8x minus 35. We're going to use the quadratic formula. All right, and it might be easier on this one. It's not necessarily required, but it might be easier if you think about making this a positive 2x squared. Basically, we can multiply both sides by negative because 0 times a negative 1 is still 0, but then it would change all of these. So we could just rewrite this as positive 2x squared plus 8x plus 35 equals 0. All right, nothing changed because I multiplied every term by a negative 1. It just made these all positives. So now I'm going to use my quadratic formula. Okay, so here you can see I have filled everything out with my negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, when we work out the discriminant, negative 8 squared is 64. And then 4 times 2 is 8 times 35 is 280. So we're subtracting 280 from 64. We get negative 216. So the discriminant's negative 216. So when that's negative, you already know you're going to have an I in your solution. That's going to be an imaginary complex number. Okay. Now 216 still needs to be simplified. That's a difficult one. Instead of dividing by 2, I went ahead and started with 3. Because I know 3 goes into 21 and 6. So 3 goes into 216 72 times. So 3 times 72. Then I did 9 times 8. And of course I know 9 is a perfect square. 3 times 3. And then 8 is 4 times 2. And of course 4 is 2 times 2. So you can see here I've circled my pairs. We have a 3 and a 2. That comes out as a single. But then 3 times 2 is 6. So that's where this 6 comes from. And then, of course, because it was negative, that's the square root of negative 1, which is I. And then this 6, you'll notice when in our factors here, we had a 3 and a 2 remaining. And 3 times 2 is 6, all divided by 4. Now we just need to simplify this negative 8 over 4 and 6i over 4. They all have a 2 in common. So negative 8 divided by 2 is negative 4. 6i divided by 2 is 3i. And 4 divided by 2 is 2. So this is our final answer right here. And that's a look at solving using the quadratic formula and getting real solutions or imaginary solutions.